What would happen if the sun suddenly turned into a black hole? Would Earth be instantly pulled in or destroyed? The sun isn't just a bright ball in the sky. It's the source of warmth and energy that keeps life going. Imagine, for a moment, that this enormous nuclear reactor, which has burned steadily for over 4.5 billion years, vanished and was replaced by a black hole of equal mass. While this idea may sound like science fiction, the physics behind it are entirely real, and the consequences would send shockwaves through the solar system, redefining the fate of every planet and moon. To understand the scale of such an event, we must first grasp what a black hole truly is. Contrary to popular belief, black holes are not cosmic vacuum cleaners, devouring everything in sight. They are regions of space where gravity becomes so intense that nothing, not even light, can escape once it crosses a boundary called the event horizon. The size of this event horizon depends solely on the black hole's mass. If the sun was somehow compressed into a black hole without losing any of its mass, the event horizon would measure only about 3 kilometers in radius, astonishingly small compared to the sun. Its current radius of around 696,000 kilometers. Surprisingly, if the sun became a black hole of the same mass, the gravitational pull on Earth would not change at all. Earth would not be drawn in, and its orbit would remain nearly identical. This seems counterintuitive, but gravity at a distance depends only on mass, not on the form that mass takes. From a gravitational perspective, Earth would continue circling as if nothing had changed, yet everything else that makes life possible would vanish in an instant. The sun is not only the gravitational anchor of our solar system, but also the source of almost all energy that drives life. Its light powers photosynthesis, controls weather, and stabilizes the climate. Without it, Earth would plunge into darkness and cold. 8 minutes after the transformation, the time it takes sunlight to reach us, the last rays of light would fade, and darkness would envelop the world. The sky would turn black, stars would appear where the sun once shone, and temperatures would begin to drop dramatically. Within a week, Earth's average surface temperature would fall below freezing, around 17 grados, bajo 00. Within a year, the planet's average temperature could plummet to minus 73 degrees Celsius. Menos 100. If the oceans would start to freeze from the surface down, though the deepest layers might remain liquid for centuries due to geothermal heat. Photosynthesis would cease almost immediately, killing plants and disrupting the food chain. Herbivores would starve, followed by carnivores, and ecosystems would collapse. Only extremophiles microbes, living deep underground or near hydrothermal vents on the ocean floor, might endure. Humanity, entirely dependent on sunlight for agriculture and warmth, would face extinction unless it could adapt quickly. The last human survivors might retreat into underground shelters or sealed habitats powered by nuclear or geothermal energy, creating artificial light and heat to sustain themselves. Psychological and biological challenges would emerge as well. Human circadian rhythms, governed by sunlight, would collapse, leading to insomnia, depression, and cognitive dysfunction. Societies would struggle to adapt to life without day and night, facing an endless, starlit darkness. Meanwhile, the transformation of the sun into a black hole would drastically alter conditions throughout the solar system. Solar-powered spacecraft would fail almost immediately as they lost their source of energy. Communication with probes like Voyager would weaken or cease entirely. The disappearance of solar radiation in the solar wind would also strip away protective effects that help shield planets from cosmic rays, exposing Earth and its neighbors to higher levels of interstellar radiation. Despite the sun's light being gone, the black hole itself would create an eerie visual spectacle. Because of gravitational lensing, it would bend light from distant stars around it, appearing as a pitch-black sphere surrounded by a distorted halo of light. The familiar blue sky would be gone forever, replaced by an eternal night filled with warped starlight and distant galaxies. From Earth's surface, it would look as though a hole had been punched through the fabric of the universe where the sun once stood. Though the orbits of the planets would remain largely stable initially, the long-term dynamics of the solar system would gradually shift. The absence of sunlight and radiation pressure would alter the behavior of small bodies, like comets and asteroids, changing their trajectories over time. Without the sun's stabilizing energy output, gravitational interactions among planets might become slightly more chaotic over millions of years. In this new dark solar system, Temperatures on every planet would fall to unimaginable levels. Mars would become even more frozen than it already is. Jupiter and Saturn's atmospheres would cool and condense, and their moons, many of which harbor subsurface oceans, might freeze solid. The Kuiper Belt and the Oort cloud would fade into complete obscurity. Every object that once reflected sunlight would vanish into darkness. In this frozen world, could humanity ever find a way to survive or even harness the black hole for energy? Theoretically, yes. Matter falling into a black hole forms an accretion disk, which can release immense amounts of energy as it heats up and emits radiation before crossing the event horizon. If humans could somehow feed matter into the black hole in a controlled way, they might generate power far beyond any source available today. However, achieving such a feat would require technology so advanced it borders on the impossible. Even approaching the black hole would pose extreme challenges. According to Einstein's general theory of relativity, time slows down in regions of strong gravitia phenomenon, known as gravitational time dilation. For an observer near the black hole, time would pass far more slowly than for someone on Earth. Minutes near the black hole might correspond 2 years in the rest of the universe, creating bizarre temporal effects. On Earth, as the centuries passed, the surface would become an icy wasteland. The oceans would freeze solid except for deep pockets heated by geothermal vents. The atmosphere within as gases condensed and froze. Wind and weather would vanish, replaced by still, silent air. The planet would become a frozen tomb, its surface coated in ice and devoid of life. Yet deep beneath the crust, warmth from Earth's molten core might sustain pockets of microbial life. Humanity, if it managed to endure, would likely evolve into a species adapted to artificial habitats, living underground or in sealed domes, powered by fusion or geothermal energy. Future generations might know the sun only through records and myths, never seeing daylight again. The world above would remain dark and still, orbiting a black hole that exerts the same pull as the star that once nurtured it. Over immense timescales, even the black hole itself might change. If Namata fell into it, it would remain invisible, slowly evaporating over trillions of years through Hawking radiation, a process so slow that it is negligible on human time. The solar system, once vibrant and bright, would become a cold graveyard of frozen worlds orbiting a silent singularity. This thought experiment reveals not only the incredible power of black holes, but also the profound fragility of life on Earth. Underscores how completely dependent we are on our sun, not just for warmth and light, but for the very structure of time, energy, and biology that define existence. Without the sun, life's complex web unravels almost instantly. Even though gravity would keep Earth safely in orbit, the absence of light would doom the planet to darkness, cold, and extinction. The image of a black circle in the sky, surrounded by a halo of bent starlight, serves as a haunting reminder of how easily the conditions for life could vanish. Humanity's only hope would lie in adaptation and technology learning to generate artificial sunlight, harness energy from Earth's core, and preserve ecosystems in controlled environments. The sun's transformation into a black hole, while purely hypothetical, highlights the cosmic balance that sustains life and how dependent we are on one ordinary star in a vast universe. A black hole might preserve our orbit, but it could never replace the sun's warmth, light, or life-giving energy. In the end, Earth would remain bound to the same gravitational pull, circling endlessly around a dark and silent center. The world would grow colder, quieter, and lonelier with each passing century, until only traces of what once was remained. This scenario forces us to confront the stark truth of existence, that all life, all civilizations, and all beauty on Earth depend entirely on the light of a single star. Should that light ever vanish, the universe would reclaim its ancient darkness, leaving humanity to face the ultimate test of endurance, ingenuity, and will to survive in a cosmos that has gone eternally dark. If you enjoyed this, please like and subscribe. Thanks for watching.